Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you for the time given. I would like to present my paper entitled Geological, Geochemical, and Radiometric Study of Sandstone-type Uranium Deposit Exploration in Menukung area West Borneo. Me, Wira Cakrabuana, I write this paper with Ekky, Argianto, Roni, Ciputra, and Dhatu Kamajati from Center for Nuclear Minerals Technology, Badan Tenaga Nuklir Nasional, or BATAN. This is my brief CV. I work as a scientist at Badan Tenaga Nuklir Nasional. My education background is I'm Bachelor of Science or Strata 1 Geological Engineering ITB. My working experiences, I was laboratory assistant at Geological Engineering ITB from 2016 until 2018, and then I was intern at PIT49IAGI-P-190-04 in 2018, and last I was a freelance geologist at PT ITB from 2018 until 2019. This is the outline of my presentation today. First, the introduction. This is the background why we do this study. The study respecting uranium mineralization in West Borneo has been carried out since 1969. The study is focused to explore the occurrence of metamorphic-type uranium deposits in Kalan area. Based on previous research, it is concluded that mineralized uranium in Kalan area is originated from small tonalite and hosted in Pinot metamorphic. As uranium exploration develops, the International Atomic Energy Agency, or IAEA, introduced the Sandstone-type Uranium mineralization concept that offers a more cost-effective mining process. The Bida formation, dominated by sandstones, which overlays small tonalite, appears the hypothesis of Sandstone-type uranium mineralization occurrence. Geological mapping, geochemical sampling, and radiometric survey are undertaken in the Menukung area, West Borneo, to prove the hypothesis. And then the basic theory. So this is the location map of my study area. The study area is administratively located in Menukung and Elah District, Malawi Regency, West Borneo Province. According to the UTM coordinate system, the study area is 20 times 20 kilometers square in extent and located on these coordinates. This is the roadmap of the study area. So the study area is approximately 100 kilometers away southeastward from BATAN Nuclear Minerals Office in Nangatuna District. This area can be reached by a two-wheel or four-wheel vehicle. The track is 75% asphalted and the rest is a rocky track leading to the study area. Based on the interpretation of the dam image, Menukung area consists of hills on the southern part and a low plain on the northern part. This is the regional geological map from Amiruddin and Trail 1993. So the Menukung area consists of three geological formations. From the oldest to the youngest, they are first Pinot metamorphic, the blue one. The Pinot metamorphic is carbonaceous to tertiary metamorphic rocks, consists of phyllite, schist, plate, and then metatarp, and then quartzite. And then the second one is sphagnolite, the pink one. The sphagnolite is lower Cretaceous plutonic igneous rocks, consists of granite, granodiorite, and tonalite. And the last one is the Bida formation. The Bida formation is upper Oligocene sedimentary rocks formation, consists of fine-grained sandstone interbreeded with mudstone and siltstone, And in some places, there are some thin coal seams. So the sandstone-type uranium deposit is a uranium deposit formed in the sandstone host rock. This type of mineralization is more probable to occur in a fluvial environment than the marine environment. The prevalent host rock found are fluvial to shallow marine sandstone. It is matched or accordingly because Ciputra in 1991 said that the Bida Formation was decided as fluvial channel to nearshore marine sand. The age of this mineralization type is Paleozoic to Tertiary, matched to with the Bida Formation age. Most of the sandstone-type uranium deposits are formed in diagenetic to epigenetic zones or low temperature. Based on the mineralization morphology and geological setting, sandstone-type uranium deposits are classified into 5 types. They are basal channel, tabular, prone, tectonic lithologic, and mafic dactyls in Proterozoic sandstone, as depicted here. Most sedimentary type uranium deposits are associated with uranium-enriched geochemical province of intrusives or volcanic rocks. The geochemical detection of uranium deposits in sedimentary rock, especially sandstone-type deposits, depends on the geochemical behavior of uranium and pathfinder elements. Uranium is extensively dispersed under oxidizing condition, but is immobile under reducing condition. An anomaly may be present in stream sediment only if the ore-bearing rocks are exposed to active erosion due to the net negative charge in their clay layers that need to be balanced by interlayer cations. Clay minerals on the fine fraction of soil containing clays, colloids, oxides, and organic matters can absorb the mobile uranium ions more readily. Thus, fine-grained soil enriched with clays, oxides, and colloids are the useful pathfinder for regional geochemical exploration in the sedimentary basins. Analysis of uranium mineralization of sandstone and superficial deposits related to Paleo Valley in China and Australia resulted in 4 essential components. The first is a source rock with leachable uranium, vanadium, and potassium connected to the Paleo Valley system. The second one, Paleo Valley or basin margins as transport pathway and site of accumulation. And the third, physical and chemical environments for mineralization, like paleogeomorphology, groundwater flux, salinity, pH, and climatic conditions. The fourth is a pre and post mineralization setting for preservation, like muddy layers, faulting, erosion. And next, data and methodology. So this is what we do in our study. First, in preparation, we do literature review of previous researches, with map production, instrument setup, and roads planning. And then we go to the field to do some activities like geological mapping, geochemical sampling, radiometric survey, and data processing. After we get back from field, we do comprehensive analysis. We do production of various field database maps and write a study report. First, geological mapping. Geological mapping was conducted at 1 to 125,000 scale. The mapping is prioritized to be done along the available road access to make the activity easier. If there is a particular feature to observe and the condition is visible, the mapping can be done along the river. The mapping is started with interpreting the depth image of the area to determine the geomorphological landscape and structural lineaments. The mapping was focused to map the oxidation and reduction zones in Tabidah Formation. The oxidation zone was represented by sandstone and reduction zone was represented by claystones, siltstone, and coals. By mapping those two zones, the redox boundary could be determined as a potential uranium mineral scraping site. The sample type collected in this study was stream sediment. Geochemical sampling of stream sediment sample was referred to IAEA Geochemical Exploration Procedure. The principle of stream sediment sampling is collecting the representative sample from every river branch consistently. The collection of stream sediment samples was done by grading the wet river sediment rated 1 kilogram. The samples were grabbed using a shovel and were wrapped using thick plastic wrap. In the stream sediment, uranium and other trace elements are concentrated in the fine size fraction. Accordingly, in prospecting, grain size fraction less than 90 micrometer or 170 mesh should be analyzed for uranium concentration. As much as 0.2 to 0.5 kilogram dry stream sediment sample is needed for uranium concentration analysis. So it has to be anticipated that collected wet sample can result in dry sample as much as it. The analysis of mobile uranium concentration was conducted using Gerald Fluorometer type DM30116. In this study, radioactivity is measured by radiometric spectrometer 125, or we call the device as RS125. Before the measurement, RS125 has to be stabilized and be connected to GPS first. The measurement is carried out in survey mode and assay mode. In survey mode, the measurement is done along the field road with RS125 turned down. In assay mode, the measurement is done at every attended field station by measuring the radioactivity of a particular object. The priority of the object should be measured by assay mode is crop first, and then the environment. RS125 measures the equivalent concentration only of uranium. And then the results and discussion. First, about the geological mapping. Based on the result of geological mapping at 1 to 125,000 scale, from the oldest to the youngest, Menukung area consisted of Pinoh metamorphic unit, Ciputra unit, and Tabidah sedimentary rocks unit. Tabidah sedimentary rocks, as defined in geological map, is divided into Tabidah sandstone 1, Tabidah sandstone claystone, and Tabidah sandstone 2. Actually, sandstone 1 and sandstone 2 are alike, but they just have difference in the stratigraphic position. Some young closings, possibly subdeterminate and lignite, are observed on Tabidah sandstone claystone unit. So we can say that this unit, the green one, the Tabidah sandstone claystone, is more reductive than the Tabidah sandstone 1 or 2. And then about geochemical sampling. So this is the result of geochemical analysis of mobile uranium content. So in ppm, it ranged from 3.4 to 61.5 with mean of 17.1. By using the statistic formula, mean plus 2 standard deviation, we can get the anomaly value of mobile uranium content. We get 36.1. So 36 here, colored yellow to red. We can see here there are 3 spots of red zones. on central and western part of the study area. And then the radiometric survey, the uranium equivalent concentration in ppm range from 0 to 11.3 with mean of 2.5. By using the same formula, mean plus 2 standard deviation, we can get the anomaly of 6.6. 6.6 here, red colored. We can find some red colored anomalous zones here. So, based on all methods applied in this study, it is concluded that the Bidah sandstone claystone, the green one, is the reduction zone, and the Bidah sandstone unit is the oxidation zone. So, a redox boundary can be drawn here at the boundary of the unit as a potential trapping spot of uranium minerals. Okay, let me get the summary. First, Menukung area consisted of 5 rocks units from the oldest to the youngest. They are metamorphic unit, the tonalite unit, the Bidah sandstone 1 unit, the Bidah sandstone claystone unit, and the Bidah sandstone 2 unit. Most of rocks in the Bidah sandstone claystone unit are carbon bearing, so it gives this unit a big possibility to be uranium precipitate. Both mobile uranium content and uranium equivalent concentration show the anomalous zones on the central and western part of the study area, mostly on the Bidah sandstone claystone unit. And last, the study concluded that the Bidah sandstone claystone unit is the reduction zone, and the Bidah sandstone unit is the oxidation zone. A redox boundary can be made on the boundary of the unit. So that's all my presentation today. I'm sorry for all my mistakes. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.